The data I collected from you is just a bunch of JSON files like the one we saw earlier. Each of these contains the session ID, student name, and 8 different drawings. At the moment there are about 500 files, and you can get them from GitHub. The number is still growing, and I'll be updating it from time to time. Now the drawings are grouped together by the session, and that's not convenient in the long run, so I'll teach you how to process this raw data into a more manageable form. A dataset where each drawing is a sample. I'll also teach you how to make a data visualizer app, but the processing part we do at first doesn't really need an interface. So I'll be working with NodeJS, a back-end environment for JavaScript. To follow along, install NodeJS from the link in the description, and make sure you have the code from last time, otherwise get it from GitHub. And see you in a second. Get it? Because we're finally gonna get to see your drawings. No.
Gonna code, debug, and have fun. Coding with Radu. Coding with Radu. Gonna prototype and design. Coding with Radu. Coding with Radu. Let's code now. To test if we have Node.js installed properly, we're going to use a terminal. You can use the one here in Visual Studio Code if you want, but I'm old-fashioned and I use command prompt in Windows. We can type node --, version, and you should see it displayed there like so. We are going to be working more with the terminal today, and we have to navigate to where our project is. So this is where we built the drawing app last time, and I'm going to go to this directory here by copying the path and here typing cd space and right-click pastes it for me. And now we're in the same directory. If I type here dir, we can see the web directory right here. To work with the data, we need a place to store it. And I'm going to create here a directory, make dir data, and you can see it appearing here in Visual Studio Code as well. If you like more working with the user interface, that's also possible at this point. So this is the folder we just created. Inside it, we are going to create a new folder called raw. This is going to contain the raw information collected from the drawing app. I'm going to go inside it and paste all the data I've collected from students over the past few months. There are almost 500 submissions, each with 8 different drawings. It's really amazing. Now, each of these files contain 8 drawings, and we're going to process these to create a dataset, where each sample is a drawing. I'll go back to the data directory here and create a new folder called dataset. And inside of this dataset folder, I'm going to create 2 different folders. One will hold the JSON representation of our samples, and the other one will be in image form. I want to visualize them as well. So a folder for JSON and a folder for image. We'll do this processing using Node.js, and I'm going to create a directory here using the terminal, node, and move into this directory using cd node. In this directory, we'll create our first script. Let's call it datasetGenerator.js. It's a JavaScript file, and in it, I'm going to define some constants. In an object called constants, I will write down the paths of all the folders we have created so far. So we have the data directory, we have the raw data directory inside of the data directory, we have the dataset directory also inside of the data directory. And we have the JSON directory in the dataset directory this time. and the image directory, also in the dataset directory. And here in the dataset directory, I also want to create a file where we'll store a kind of summary for the samples. Let's call this samples. It's going to be in the dataset directory, and it's going to be a JSON file, samples.json, like this. We're going to create this file next. I'm going to use the file system, and let's read the file names from the raw data directory, like this. Then I'm going to create an array for the samples where we're going to store information about each sample. And I will initialize an ID with 1. I want to give IDs to each individual sample. Now, for each file name, let's call it fn for short, I'm going to extract the content from the raw directory, concatenating with the name of the file, like so. So this contains a string of characters, one for each of the files in that raw directory. From this string, I'll extract the session information, the student information, and the drawings by first parsing the string into JSON and then using the destructuring assignment here. Now we'll have a sample for each drawing, so I'm going to write here for label in drawings. The label is going to be what that drawing was of. I will push to the samples array a new object with the ID, the label, and now I'm going to call student name what we previously had student. And because student names are not necessarily unique, I'm going to also add here student ID session, like this. The sessions were made to be unique. Now let's increment this ID and move on to write this samples array into our samples file. I go down here like this and write file sync in the samples, a JSON stringified version of this array. Now to test this code, we're going to go to the terminal and write node dataset generator.js. And something happened. If we look here in the data and the dataset, there is a new file created called samples.json, and it looks like this. If you want this to look nicer, you can install a Visual Studio Code extension for JSON. Then you can press something like Ctrl-Shift-J and it will format it like this. But you can see now some of my drawings are here. And there's an entry here for the car, an entry for the fish, an entry for the house, tree, and so on. Then other users follow as well. Now this is just a summary here. To generate the data associated with each sample, I'm going to go here before moving on to the next item, and I'll write file sync into the JSON directory, and the file will be named after the ID .json. Simple enough. We just have to stringify here the drawing of that specific label. Let's save this and rerun our script here. In the terminal, you can simply press the up arrow and it will retype the last command. It took a little longer this time, but if we look inside of this JSON directory, you can see an entry for each sample. And if you click on it, you'll see all the data needed to make that drawing. It's the array containing all the paths, and each path contains points. Now for each of these entries, I also want to have an image representation. They will go in this image directory where we draw these paths. Essentially this. These are the paths. Let's rename this to paths, and I'm going to extract here. Paths is the drawings of label. So let's write a new code for doing that. We'll make a function called generateImageFile, and this will take the output file path in the image directory. It will be called the same, but the extension will be PNG. And here we add the paths as well. Now we'll implement this generateImageFile function here at the bottom. It will have two parameters, the output file and the paths. And to draw them, we'll use a canvas, and we'll use the draw paths function from our web application from last time. This one right here. So we're gonna go and write draw paths on the context, the paths. And we want to store these drawings as an image. So we can write here buffer, canvas to buffer, a PNG image, which we write in the output file like so. Now this won't work yet because this draw paths function needs to be referenced first. And we need to move it from here to a common place that both the web and our Node scripts can access. So let's close these to avoid confusion. And here I'm going to create a new directory called common. And in it, I'm going to move this draw.js file from here. Now, inside this file, for it to work in Node.js, we need to export this. And we do that by typing module exports is equal to draw. We want to export the entire object. And in our dataset generator, all the way at the top, we have to include this file by typing draw is equal to require ... common/draw.js. The ... here just means we go up a folder. So now the draw exists, but we still need the canvas. And unlike in the browser, here we have to install the canvas separately. We go to the terminal and type npm install canvas. And now the Node package manager is installing the canvas on our system.
Now I basically installed the library, even though I said no libraries in the course intro. To make things worse, we also used and will continue to use the math library. So I kind of lied, but the browser has the canvas there by default. And I think that we all take math and drawing functions for granted nowadays. And if you don't, sorry, but I definitely won't teach you how to draw lines or how mathematical functions are implemented. Not in this course, at least.
You can see here in the Node directory some new files appeared, and even a new folder. This package JSON just says that the canvas was installed. This gives more details, and this is where the binaries are. Now, back in our dataset generator at the top, we can require the createCanvas function from the canvas module and use it to create a canvas of 400 by 400, the same size we had in our drawing app. We can also get a reference to the drawing context, same as in the web version. And here at the bottom, we are using it to draw the paths on the canvas and then storing it as an image. But it's the same canvas for each of the samples. So I'm going to have to clear it before drawing the new paths. Now let me open this to show you what happens next. I'm going to go in Data, Dataset, Image, and in the terminal, let's type node dataset generator.js again. You can see it takes a while this time, and here our image files are being generated. And the number is growing and growing and growing. It takes longer than generating just the JSON files. And if I click this up here, you can actually see how they look like. Okay, the script is done, but now there's a problem because we broke our drawing app from last time. Down here, where we have our draw.js included, we need to include it now from ... /common. Save the file and let's try to test. You can see here it says module is not defined. And that's because in draw.js the browser doesn't know what module is. We can fix this by typing if type of module is not undefined, then we are going to do this, which will make the node code work. Now I refresh and everything still works as before. We'll be using this kind of structure throughout the course. Let's apply the same on the constants right here. We're going to separate them in another file. I will require the file here. It will be constants.js, and we will take out the constants here like so. And now I'm going to cut all this code from here. It's in my clipboard. Save this file, and in common I will add a new file called constants.js. I paste everything from earlier, and at the bottom we need to type if the type of module is not undefined, we export the constants. Now if we go back to the terminal and rerun the script, it works, but it's slow and it would be nice to have a progress indicator here. I'll implement one in a new file called utils. Let's write here utils.js, and we create a utils object, and in it let's add a function called print progress with two parameters. It will have a count and a max value. When the count reaches max, it's 100%. Now we'll use process stdout to get the standard output. We clear the line and we move the cursor in the standard output back to 0. This will essentially delete the line in the console. Now we can calculate the percent. I'm going to implement a function for formatting a percent in just a second. So that will be format percent of the count divided by max. I just want it to look like a percent value. You'll see. And then we'll write to the standard output like so. First, how many from the max are there? And then I'm going to concatenate with this percent in parentheses like this. Above here, I'm going to implement this format percent function, which just takes a value and it's going to return the value multiplied by 100. And then I want to have a 2 decimal precision here. I will also concatenate the percent symbol. Now let's export this object down here. If type of module is not undefined, we add it to the exports. Save the file and let's include it next in our dataset generation here at the top. Let's copy this. Utils, and here I'm going to write print progress according to this ID. So the ID is going to be the count, and then the maximum value is actually the number of files in that directory multiplied by 8, because each file contains 8 drawings. Let's save this, rerun the script, and now we have a nice progress indicator here. Now keep in mind that these images are already here, and what this script is doing is regenerating them over and over again every time we run it. I just did this to teach you about the file structure and the progress indicator. Okay, it's done. Now we're going to start building a web application that can display this dataset. But before that, we need to store it in a way that the browser can read it as well. I'm going to go here in Common and create a folder called JS_objects. This folder is going to contain files we use to communicate between our Node scripts and the web apps we're going to make. I'm going to go to constants.js and add here a path to this JS objects directory, like this. And here we're going to create a samples JavaScript file similar to the samples JSON, but it will initialize a JavaScript object in it as well. You'll see. Inside of JS objects, and it will be called samples.js this time. We write this file in dataset generator at the bottom by copying this, adding here samples_js, and instead of just stringifying here, I'm going to add const samples is equal to, and I will concatenate with this string and add here a semicolon at the end. Now let's rerun this script. We can see the file now here. It's essentially the same as samples, but with this beginning part right here and a semicolon at the end.
Now, this kind of structure I'm using here is not really standard, and I won't go into much detail as to why I chose it for this course. But in short, it's to avoid course. I thought the web server is too much trouble, and the VS Code live server extension is buggy with some of the things we'll do later, at least on my computer. But feel free to reorganize this if you have better ideas.
We are going to create a viewer app for our dataset here in the web part. Let's create a new file, viewer.html, and begin to write some basic HTML. In the head, I will include this meta tag for supporting UTF characters, and the title will be Data Viewer. We'll also link the external style sheet from the same directory, styles.css. Let's close the head, and in the body, I'm going to start by writing the title in an h1 tag, Data Viewer, and let's have here a div with an ID of container. This will contain the dataset. Let's close this div and include our samples JavaScript file we just created. We're going to need a few other JavaScript files from Common. I'm just going to copy this 2 times, and here I'm going to include constants.js and here utils. Now here I'm going to open a script tag, and let's just log those samples to see if we have them in the browser. Close the body and the HTML tag. I'm going to save this and open this viewer HTML, and there they are in the console, our samples, all 3,968 of them. We can investigate them here, what they are, who made them, and so on. Next, I want to create a table with these samples so that each row are all the samples from one specific user. I'm going to have to group these by the student ID. Let's go to this utils.js and implement a group by function there. Here at the bottom, let's type utils group by, a given array, and a given key. It's going to be a general function that can group by any key. In our case, we'll use student ID. Let's initialize the groups as an empty object. And for each object of object array, I'm going to get the value of that key. If this groups of that value is null, in our case this means if the student ID was just identified, we don't have any drawings from them yet, we initialize it with an empty array. And then we push to that student ID the whole object and return these groups. Now in viewer HTML, let's remove this log and first get the groups by grouping by the student ID. And let's log these ones now to see how it works. Save the file, refresh, and you can see the output is a little bit different this time. If we open it up, I can see for each student ID, I have 8 different samples. The car, fish, house, tree, bicycle. So these are per user. Miguel Fernandez in this case. Let's create a table next. So I'm going to loop given each student ID like this. I'm going to refer to the samples as the groups of this student ID. And let's take out the student name as well for clarity. I just take it from the first sample, student name, like so. And let's create a function called createRow that on a given container, in this case our div from above, it will display a row with the name, the student name on the left, and then the samples one after the other towards the right. Let's close this for loop, and we'll use this createRow function in other applications as well. So I'm going to write it in a different file. It's going to be a file called display.js in our JavaScript directory here. So let's create it, display.js, and the createRow function goes in here like this with the 3 parameters. And first we create a row, which is going to be a simple div. We create the div. And let's add the styles for these as well. We'll have to modify the CSS afterwards. I'm going to add a class for this row. Let's call it row. And append to the container this div, like so. I will continue now with the label, which is also going to be a div. And I'm going to set the HTML of this div to be the student name, the second parameter. Now, also a class for the label. Let's call this row label, which we can control in CSS, and append to the row label. So our div from previously now has the label to begin with. And below, we're going to loop through the samples and add each of them independently. Sample of samples. I will take out here just the ID and the label of the samples. They are really all that we need. And I'm going to create an image element next, like so. And I will assign the source of this image to be the path of this image file. I'll take that from our constants image directory and concatenate with the id.png. That's where the file is. I'm also going to add a style for this image. Let's call this thumb. It will be a thumbnail size. And append each of these images to our row. Let's close this create row function, save the file, and if we refresh the page, we can see something here. It's Radu and then some drawings here. And then another Radu. I actually drew twice. Then Yasin and so on. But these don't look good without the CSS. I'm gonna go at the bottom here and add the row using display flex. And the thumbnail will have a width of 10%, and the row label will have a little bit wider width so that we can see the name of the person. Let's save this, refresh. Wow, it looks like the Finnish Prime Minister is here. Hello. I don't believe it's actually her, but who knows? In this day and age, everyone learns coding. Okay, but we can do better. Long names like this don't really fit in. And also, the names here don't really align with the center of the samples here. I'm gonna fix that by writing here align items to center. And for the row label, I'm gonna add ellipses. So text overflow set to ellipses. I'm gonna hide the overflow and no wrap for the white space. Let's save this, refresh. Sorry, Gustavo, but it's okay. When we watch this on a larger screen, all the text will appear there. Now I want these drawings to have a white background each, so I'm going to go to display.js here and wrap them inside of a div, a sample container. Create a div, and I'm gonna add an ID to this div. We'll need it later. It's gonna be sample underscore and the ID of the sample. It's gonna uniquely identify it. I'll also add a class to this. Let's call it sample container. And I'm also going to add the label, the true label of this object, what it is. So it's going to be another div where we set the inner HTML to the label and we append the label to this sample container first. Then here, after we have the image, I'm also going to append it to the sample container. And below here, where we append to the row, we don't append the image anymore, we append the sample container. Okay, save the file, refresh the page, and it's worse than before. But that's okay, we'll fix it in CSS. I'm gonna implement the class for the sample container first. We'll give it a white background, text align to center, border radius 10%. I want it to have round corners, and margin 1 pixel. Now I'll explain this flex part a little bit later. Let me also modify now this thumbnail here to be 100% this time, and the row label will have this property here. Let's save this, refresh, and what happens now is that horizontally each of these 8 different samples are taking 10% of the space, and 20% of the space is taken by this label on the left. That's what this 2 here is for. And the other ones are just 1, so that's why this 1 here is for. You can see that this bicycle doesn't fit very well here. And if I'm going to zoom in, others have issues as well. It's because they try to fit in the text here. I'm using a very small screen here. We're testing, so this is not really a big deal. This will be a desktop application, not a mobile app. But we can do a quick fix here by typing an overflow of hidden to the sample container, save the file, refresh the page. And now the structure is good, but the text doesn't fit entirely. But it's not a big deal. On a normal zoom level and a larger screen, it's just fine. Now, before we look a bit through these drawings, I have to talk a bit about flagged users. You see, some people made some drawings that I think might get me in trouble. I'm gonna go to utils.js and add here who they are. Flagged users. And I'm going to paste here an array I created earlier that looks like this. These are their IDs. Now in display.js, I'm going to destructure here to take out the student ID as well. And then here where we have that image, I'm going to write if the flagged users includes this student ID, I will add the class to blur it. In CSS, we'll define this blur class, where we just apply the blur filter with 5 pixels, like this. Let's save this, refresh the page, and now we can have a look at the data. Let's make it bigger. Okay, my 2 drawings are here that I did in the beginning. And then, wow. This might be Bo from Free Code Camp. He also commented on YouTube using emojis. I got an idea from that. You'll see. Another me. Awesome. Wow. This one is really nice. Oh my. This house is amazing. Some text here, this is going to be tough. Wow, some of these drawings are... How long did you spend on this? This is funny. I think some of you thought that it says horse instead of house. I've noticed some of these problems. No big deal, it makes the data more challenging. Wow, this is a really nice car. Giving me mafia vibes. Okay, this is something. We'll have to talk about data cleaning at some point and how it improves the models. Wow. These are amazing. Look at that. You know who you are. Wow, very different looking tree here. Wow. And the Christmas tree. Oh, this is fitting. It's soon Christmas when I'm filming this. And a couple of more horses here where the house should be. I'm quite sure these are honest mistakes. Look at this. Wow. Basic coder, but not so basic drawings. I don't know why I'm thinking about Magikarp now. Ah, Jinzon Ningen Junanago.
As you can see, some of these drawings are really detailed and must have taken a really long time to draw. That makes our data slightly different than the one from Quick Draw. They have a time limit. We also have an undo button to fix mistakes, so our drawings should be better on average. Think you can organize or style the page in a better way? Share your version with me and I'll showcase my favorites in a future video. Next time, we extract features from the data.